In this session, we'll studying more about differential equations. Okay, we know what is a differential equation. A differential equation is basically an equation which contains derivatives. So basically, a differential equation is an equation which contains derivatives. And we know derivatives are of two types. They are ordinary derivatives and also partial derivatives. Okay, so ordinary derivatives, what is the property of ordinary derivatives? It contains one dependent variable and one independent variable. Okay, so one dependent variable and one independent variable, for example your dy by dx stuff. Okay, and what are partial derivatives? In partial derivatives, the idea is it contains one independent variable there. Okay, so it contains more than one, sorry, it contains more than one independent variable. Okay, so since the derivatives are of two types, we can also classify differential equations into two. So they are called ordinary differential equations and also partial differential equations, depending upon the type of derivatives there. Okay, so you can say that in an ordinary differential equation, they contains only one independent variable. Okay, and in a partial differential equation contains more than one independent variable, so there are partial derivatives there. Okay, so there are more than one independent variables. Okay, so I hope it is clear what do we mean by ordinary differential equations and partial differential equations, and we have studied many of these properties in our earlier classes also. Okay, so you know what's a differential equation? An equation which contains derivatives are called a differential equation. Since the derivatives are of two types, ordinary and partial, you can also have two classes of differential equations called ordinary differential equations which contains one variable, and also partial differential equations which contain more than one independent variable. Okay, so that is the classification there. Okay, and we also studied many properties and solution techniques regarding to this differential equations. First of all, we know what do you mean by solution. Okay, so if you have a differential equation of the form, for example, if I have a differential equation of the form dy by dx is equal to maybe dy by dx is equal to y. Okay, so it's a very basic differential equation. And what's the solution of this equation? The solution of this equation is actually a value of y. Okay, a value of the function y which satisfies the equation. Okay, suppose if I put y is equal to e raised to x. Okay, the value of y. So if I just substitute the value of e raised to x into this equation, I'll get that d of e raised to x by dx, which is same as e raised to x, is same as the y. Okay, so you can say that y is solution. So the solution of a differential equation is a value of y which satisfies that differential equation. So that's a very simple thing. So I hope it is clear what do you mean by differential equation and its solution. Okay, and for our purpose, we will only be focusing on ordinary differential equations in this semester. In the next semester, we will study more about partial differential equations. Okay, so for our all practical purpose, our derivatives will only contain ordinary derivatives. Okay, so we will be focusing only ordinary differential equations in this semester here. Okay, so moving forward, we have studied many terms related to a differential equation. You know what do you mean by order of a differential equation, right? So what is an order? So order is basically the highest order derivative, is the order of the highest derivative that occurs there. Okay, for example, if a differential equation is like this, so you have to understand some notation here. I will not be using the notation of dy by dx is equal to y. I will be using the notation of y prime or y dash is equal to y to denote derivatives there. So usually I'll write like this: 2y double dash minus 2y dash is equal to y. This means actually it is 2 d square y by dx square minus 2 dy by dx is equal to y. So usually we will be using this notation of y dash, y double dash, etc. to denote a differential equation here. Okay, so I hope what you mean, what's an order now. So order is basically the order of the highest order derivative occurring in that differential equation. For example, if you look at this equation, for example, it is 2y double dash minus 2y dash is equal to y. So what's the order of this differential equation? The highest order derivative occurring in this equation is y, is the y double dash. So order of this equation is 2. Okay, for example, again, for suppose it is y dash square minus y double dash plus y triple dash is equal to maybe sin x. Suppose this is an equation. What is the order here? Here the order is 3 because the order of the highest order derivative here is actually 3 here. Okay, so I hope it is clear what do you mean by order. Okay, now the related concept is degree. Okay, so what is degree? Degree is basically the power of that highest order. Okay, so power of that highest order is called the degree, provided the differential equation is free of radicals or negative powers. Okay, for example, if you look at this equation, the degree is actually 1 because the highest order derivative here is y triple dash and its power is actually 1 here. Okay, suppose the power was 2 here, the degree would be 2 positive equation. Okay, similarly, if my equation is like this, y double dash plus y dash raised to minus 1, okay, plus maybe sin x is equal to 0. What is the order here? Order is actually 2 here. Degree is actually 1. So before that you have to make all the negative powers to be, you have to remove all these negative powers. So it will be like this is actually y double dash plus 1 by y dash plus sin x is equal to 0. Again it is y double dash y dash plus 1 plus sin x plus y dash. So when you look at this differential equation now, you can see that this differential equation is now free of negative powers and radicals. So you can now tell the order here. The order of this differential equation is 2 and the degree is actually 1 because the power of this term was actually 1. So I hope it is clear what do you mean by order and degree. It is, we have studied all these concepts in our lower classes. Okay, so I hope it is clear what do you mean by order and degree. Okay, and you know that in most engineering mathematics, what you do is that you will have a physical problem there. Okay, so you need to find a solution to this physical problem. You need to find some some solution to this problem, some innovative solution to the problem. So what you will do is that I'll just take the bare essentials of that physical problem and I'll prepare a mathematical model. Okay, so this mathematical model, it may contain so many variables will be there in that model. So it can contain some dependent variables and there are some independent variables. So many things will be there. So most probably when you model a physical problem, you will get a differential equation. Okay, and then what you will do is that you will solve that differential equation and you will get the solution to the differential equation. Okay, so once you get the solution, you will interpret the solution in terms of this physical problem to get back the solution to the real life problem. Okay, so we have a physical problem, you prepare a mathematical model, so it is now simplified. Now you will use many techniques to solve that differential equation. You will get a solution. Now you use that solution to interpret the physical problem. Okay, so that is what is engineering mathematics is about. So this is the differential equation forms the crux of most of engineering mathematics problems. Okay, so basically that's the idea. And here you can see some examples of differential equations. We have only included ordinary differential equations because we are only focusing on ordinary differential equations here. You also have studied more partial differential equations, like I think you have seen like this, dou square y by dou x square plus dou square y by dou y square is equal to 0. This is a Laplace equation. So this is a partial differential equation. So here we will only be focusing on ordinary differential equation. Okay, and now for example, suppose my equation is y dash is equal to cos x. Okay, now can you tell me solution of this one? What will be y dash is equal to once? How will you find solution of y dash is equal to cos x? Okay, it's very simple. You can just integrate it. What will you get? You will then get the answer as y is equal to when you integrate, you will get the answer y is equal to sin x plus some c. Okay, so the solution to this differential equation is of the form y is equal to sin x plus c. So y is equal to sin x is a solution, y is equal to sin x plus 2 is a solution, okay, etc., etc. So this will be called the general solution. We will come to that later. And this solution obtained by given some particular values to this general solution is called a particular solution. Okay, so usually in some differential equation problems, you will have a differential equation plus they will give you an initial condition. Okay, they will tell you that maybe y of 0 is equal to 2. Okay, they will say that y of 0 is equal to 2. So from that you can find out the constant there. Okay, for example, in this problem in which we had studied y dash is equal to cos x, we know that the solution is y is equal to sin x plus c. I don't know the value of c, it depends upon the problem there. Okay, so they are giving you a value that suppose y of 0 is equal to 2. So can you tell me the value of c now? So you just substitute the value of x, put x is equal to 0. So see what you get for y. So when you put x is equal to 0, you will get that y is equal to y, the value of y will be 2 and your RHS is 0 plus c is c. So the value of c is 2. So you will get the answer as y is equal to sin x plus 2. So such type of problems in which a differential equation plus an initial condition is given, such problems are called initial value problems. Okay, so it will contain a differential equation plus an initial condition there. Okay, so I hope it is clear what do you mean by ordinary differential equations, the order, degree, initial value problem, and etc. Okay, so now we will study some methods that. So before that, let us focus on what do you mean by linear differential equations. Okay, so this is what we will be focusing in this module here. So we will be basically focusing only on linear differential equations. So what are linear differential equations? A linear differential equation is basically an equation which is linear in y and its derivatives. That's the idea. So it's a differential equation which is linear in y and its derivatives. So what do you mean by linear equation first of all? Before we focus on linear differential equation, what do you mean by linear equation? Okay, so linear equation, you have seen that the equation of a line is linear equation. Okay, so you know that 2x plus 3y is equal to 5. This is a linear equation. Okay, and similar, you know that x square plus x is equal to 2. This is not linear, this is a quadratic equation. Okay, so you know that in a linear equation the power of the variables will be 1 and they will not be multiplied together. Okay, so basically xy is equal to 3. This is not a linear equation because the variables are being multiplied there. Okay, so a linear equation is an equation in which the variables have degree 1 and they are not multiplied together. Okay, so a linear differential equation and the first order of a linear differential equation here means, so it will be a linear equation in y and its derivative. So basically it will be a linear equation y, y dash, y double dash, etc. Okay, so that's the meaning of linear differential equation. Okay, which we'll be focusing on here. Okay, so the one important thing I have to realize is that, for example, here y is equal to y dash plus x. This is a linear differential equation. Okay, and similarly, um, y square is equal to y dash. This is not a linear differential equation because you have a power of 2 there. Okay, similarly, xy minus y dash is equal to 2. This is a linear differential equation because I have only told you that this has to be linear only in y dash and y double dash. So x can be anything. So even if it is x square into y minus y dash is equal to, this will still be a linear equation because we are telling defining linear equations as only those equations which are linear in y and y dash. Okay, so which are linear in the dependent variables and its derivative. So we are defining a linear differential equation as a differential equation which is linear in the dependent variable and its derivatives, and they are not multiplied together. Okay, for example, y dash plus x is equal to 2. This is not a linear differential equation because we are multiplying the y and y dash. So I hope it is clear what do we mean by linear differential equation. It's a linear differential equation is a differential equation which is linear in the dependent variable and its derivatives. Okay, so x can be anything. The independent variable can be come in other powers and everything, so it doesn't matter. What only matters is that you have to look only on the dependent variables and its derivatives. If their powers are 1 and if they are not multiplied together, we will call it as linear differential equation. Otherwise it will be called non-linear differential equation. For example, you can see that this is a non-linear differential equation, this one here is a linear differential equation. Okay, so now we will also study the standard form of a linear differential equation. The standard form of a linear differential equation we will be focusing on. So the standard form of first order linear differential equation is that in a first order equation they will have y dash would be there, y would be there. So usually I can write it as y dash plus maybe some function of xo, some g of x into y is equal to some f of x. So this is the standard form of a first order differential equation. Okay, so there will be y dash will be there, its power will be 1. There will be a factor involving y would be there, its power would be 1, and they can also contain coefficients of x that can be anything. Okay, for example, y dash plus x square into y is equal to x cube. Okay, this is a standard form of linear differential equation. Okay, so even if it is like, suppose it is like x square y dash plus xy is equal to e raised to x. Still I can make this, and this is not a standard form, I can make it into a standard form by dividing by x square. So it will become y dash plus 1 by x into y is equal to e raised to x into x raised to minus 2. So this is the standard form there. Okay, so the standard form is like maybe if you will write it x dash y dash plus some p of x into y is equal to q of x. So this is the standard form of a first order linear differential equation. I hope it is clear. These terms here, first order linear differential equation, first order linear differential equation. Okay, now what will be the standard form of a second order linear differential equation? What will be the standard form of a second order linear differential equation? Remember that it will contain y double dash would be there, y dash would be there, y would be there, then some terms involving x also would be there. Okay, so the general form is like this: y double dash plus some p of x into y dash plus some q of x into y is equal to some r of x. Okay, so this is the general form of a second order linear differential equation. Okay, so you can see that the powers of y double dash, y dash and y are 1 and they are not multiplied, and x can be anything, so it can be like y double dash plus x cube into y dash plus e raised to minus x into y is equal to sin x into x square. Okay, so these are second order linear differential equation. Okay, so once you write a linear differential equation in the standard form, if the RHS is 0, that means the term which does not contain independent variable, the terms which does not contain dependent variables are 0, this equation will be called homogeneous equation. Okay, so these are the most simple differential equations. So what is a homogeneous equation? So once you write write the equation in the standard form and the RHS is 0, that means those terms which does not contain the dependent variables are 0, such equations are called homogeneous equation. For example, its general form will be for a homogeneous linear differential equation will be y dash plus p of x into y is equal to 0. For example, y double dash plus x square y is equal to 0. So there is no term involving which does not contain y. There is no term which does not contain y here. Okay, so terms involving independent variable alone are absent here. Okay, so earlier we could write it as y double dash plus x square plus y is equal to e raised to x. So this is not a homogeneous equation because there are terms which contain independent variable alone. Okay, so Homogeneous are equations in which there are no terms which does contain independent variable alone. Okay, so those terms would be 0 actually. So this is a homogeneous differential equation. This is a non-homogeneous differential equation. So I hope it is clear. A homogeneous differential equation is an equation in which there are no terms which contain independent variables alone. Okay, always there will be a all terms would contain either the dependent variable y or its derivatives. Okay, so that is clear. So I hope all these terms are clear. So what have we studied till now? We have studied about ordinary differential equation. Okay, we have studied about order, and we have studied about linear differential equation. Okay, we have studied the general form of linear differential equation. Okay, and we have written the first order linear differential equation and also the second order linear differential equation, general form. Okay, and now lastly we have studied about homogeneous differential equation. Okay, so these are some terminologies we will be familiar with. So I hope it is clear here. Okay, and moving forward, you can see the definitions that I have written definition here. Okay, so this is standard form which you have written already. The standard form is this. Okay, and here I have given you an example of a nonlinear first order. So basically this is an example of nonlinear first order differential equation. Okay, so here you can see a nonlinear first order differential equation. You can see an example of a first order linear differential equation in standard form. Okay, I have written the standard form of that equation. Please go through that. And similarly, homogeneous linear differential equation also we have discussed. I have given you an example here. Okay, so moving forward, we have studied. I also have told you what do you mean by second order linear differential equation. So this is standard form here. Okay, and similarly, the homogeneous will have the form this because the RHS would be 0 there, and you can see that this is a non-homogeneous linear ODE. I hope all these terms are here non-homogeneous because there are terms which contain X only. Linear because the dependent variable and its derivatives are linear here, and ODE. So everything is, I hope it is clear by this example. If you look at this example, okay, and similarly you can see a homogeneous linear ODE here. It is written the standard. So there are no, you can see that there are no terms which contain X alone. So it's a homogeneous equation, and this is standard form here. Okay, and an example of non-linear ODE is this one, and you can see that this is homogeneous also because there are no terms which contain X alone. So this is a homogeneous non-linear ODE. Okay, so just try to understand these terms. There is not much is required. You will only have homogeneous one and non-homogeneous ones to start study now. So just try to understand the meaning of all these terms here. What do you mean by homogeneous? What do you mean by linear? They won't be asking you the definitions, but you have to understand the concepts. That's enough. Okay, they won't be asking you what do you mean by homogeneous equation? What do you mean by linear equation? What do you mean by non-linear equation? They won't ask you. You just need to understand the concepts only. Okay, so just go through the examples and try to reinforce the concepts. Okay, now we will try to solve. So next will be try to interest in the solution of this homogeneous. So now onwards we will only focusing on homogeneous equations. So we will only be focusing now onwards on homogeneous linear differential equations. Okay, in particular in the first section we will be focusing exclusively on second order equations. Okay, so first we will be focusing exclusively on second order equations. Later we will carry over to higher order. Okay, so in first section we will be now focusing on homogeneous linear differential equation. Okay, an important property of this homogeneous linear equation is, for example, suppose y double dash plus y is equal to 0. So you can see that this is a homogeneous second order linear differential equation. Okay, so we will devise, I'll tell you the methods to find the solution here, but suppose, can you find two solutions here? So if you think hard, you can see that y is equal to sin x would be a solution, y is equal to cos x also will be a solution. Okay, so later on we will discuss methods in which you can find the solution, but still if you have some practice in integral calculus, you will know that if you look at this example, so you will know that y is equal to sin x and y is equal to cos x is a solution. Okay, so y is a solution. If you just substitute it, what you look at it as, if you substitute sin x, you will have when you take the second derivative, you will have cos x minus sin x. So minus sin x plus sin x would be 0, so it's a solution. Similarly, if you put cos x, that will also be a solution. Okay, an important property of the solution set of this. So we are going to try to study the solutions of this homogeneous. Suppose we are going to study the solutions of this homogeneous equation. Okay, so we can see that if sin x is a solution, or if cos x is a solution, sin x plus cos x also would be a solution. That's a very important observation we are going to make. Okay, so can you check it out? So how will you do it? So if you just substitute sin x plus cos x, well, the first derivative would be cos x minus sin x. The second derivative would be again minus sin x minus cos x. So this is your y double dash, this is your y. So if you add them, you will get the answer of 0. So if you have two solutions, suppose y1 and y2 are solutions, an important property of this homogeneous equations are y1 plus y2 is also a solution. Okay, and you can actually improve it actually. So if you again, if y1 is a solution, you can also see that 2y1 is a solution. Okay, so if sin x is a solution, you can check that 2 sin x is also a solution. If you substitute 2 sin x, what will have? What will you get? Y double dash would be again minus 2 sin x. So when you add, you will be 0. So 2 sin x also will be a solution, and similarly 3 cos x also will be a solution. So that you can generate many solutions using these solutions. Okay, so that means generally if you have a homogeneous linear ODE, the property is that if y1 comma y2 are solutions, then their linear combination, we call this term c1 y1 plus c2 y2 as a linear combination. Their linear combinations also will be solutions. Okay, so linear combination of solutions will also be a new solution there. For example, what do we mean by linear combination? That is nothing is there. For example, the linear combination of x and y is simply 2x plus 3y or 3x plus 4y. Here I'm just writing it in general form. Okay, so a linear combination of two variables x and y is simply ax plus by. So that is the concept of a linear combination. Okay, so the linear combination of y1 comma y2 is basically some constant c1 into y1 plus some constant c2 into y2, and we claim that this is also a solution. Okay, so this is true for linear differential homogeneous. This is true for only homogeneous linear differential equation. We will see why it is not true for other equations, but try to understand this result now. If y1 comma y2 are solutions, you can generate more and more solutions using this term, that is c1 y1 plus c2 y2. Okay, so this theorem is called the superposition principle. So they can ask you state and prove the superposition principle for linear homogeneous differential equation. So this principle is called, very simple thing, is called the superposition principle. Okay, so I hope it is clear. What do we mean by superposition principle? Okay, so what is superposition principle? So you can see that. So I have written here. So the linear combination of two solutions is again a solution. Okay, so this is the idea of that. So for example, we have given example also here. You can just check it out that 2 cos x minus 3x is also sin x is also solution. So the linear combination of the solutions is also a solution. So that's the idea of that. The name of this principle is actually superposition principle. So I hope it is clear. Okay, so let us try to prove it. There's nothing to prove. You can actually, it's basically computational work. You can try to prove it yourself. Okay, suppose how will you prove it? Actually, it's very simple. You take two solutions y1 and y2. So suppose y1 and y2 are solutions. So what does that mean? That means that y1 and y2 will satisfy this equation. So we will have y1 double dash plus some p of x into y1 dash plus q of x into y1 is equal to 0. And similarly y2 dash is y2 is a solution. So we will have y2 double dash plus p of x into y2 dash plus q of x into y2 is equal to 0. Why is it so? Because both of them are solutions there. Okay, now you have to show that c1 y1 plus c2 y2 is also a solution. That means if you substitute this c1 y1 and c2 y2 in this equation, you should get the value as 0. So what will you get? So when you substitute c1 y1 and c2 y2, you will get this as c1 y1 plus c2 y2 to the second derivative, okay, plus p of x into, again, I'm just substituting it. So you'll get just c1 y1 plus c2 y2 to the first derivative plus again some q of x into c1 y1 plus c2 y2. Okay, I don't know the value. I have to show that it's equal to 0. Only then it will become 0. So when I take the derivatives, what will the derivative be? So using the linearity property of derivatives, you know that it will be simply c1 y1 double dash plus c2 y2 double dash. Okay, why is it so? Because you know that the derivative of 2y plus 3, so maybe 2y plus 3z, not 3z, but suppose. So what is it? Derivative of 2 into some f of x plus some 3 into g of x. What's the derivative of this? Just 2 into f dash x plus 3 into g dash x. That's called the linearity principle. So applying that principle, you will get this as second order derivative of this will be simply c1 y1 double dash plus c2 y2 double dash plus again you will have p of x into, okay, what is it again? c1 y1 dash plus c2 y2 dash again here plus q of x into c1 y1 plus c2 y2. So I just substituted the value of c1 y1 and c2 y2 there, and then just I brought the properties of the derivative there. Now I am going to group terms involving y1 double dash. So we group terms involving y1. So what will I get? I will get this as c1 y1. So c1, if I take it outside, I will get this as y1 double dash plus p of x into y1 dash plus you have q of x into y1. Okay, plus now I am going to take terms involving y2, so we will have c2 will be outside, the rest of everything will be y2 double dash plus p of x into y2, p of x into y2 dash, p of x into y2 dash plus q of x into y2 is equal to 0. Q of x into y2 is equal to 0. So you will be getting the value of this now. So so when you substitute all these values, you will see that y1 double dash plus p of x into y1 dash plus q of x into y1 and c2 into y2 double dash plus p of x into y2 dash plus q of x into y2 is there. So what will you get? So you know that this term, that is c1 into this term, you know that this is 0 because y1 is actually solution of the equation, and similar to c2 in this term will be also 0. So you will be getting this as actually 0 there. Okay, so you got that. So that is the proof of that theorem. It's a very simple theorem now. I hope it is clear. Okay, so very simple thing, you just take the two solutions y1 and y2, then you apply the meaning of the solution to that. Okay, then you have to show that c1 y1 plus c2 y2 is also a solution, so you can easily put it down there. Okay, so I hope it is clear. Okay, so that is so they can answer the question which can come from the section is to state and prove the superposition principle. It's a very simple thing. Okay, and moving forward, we have to also remember one thing here is that it does not hold for other equations. This is only true for the superposition principle, is only true for linear homogeneous differential equation. Okay, it is not true for non-linear equation. It is not true for non-homogeneous equation also. Okay, so I have given you some examples here why it is not true. You can see this example here. So if you look at this equation, y double dash plus y is equal to 1. This is a linear non-homogeneous equation. We have written two solutions here. Okay, so you can check whether they are solutions, and if you add them, you can see that and it will not be a solution. Okay, so if you just add them, you will get as if you even add them, or if you take the scalar multiple of them also, you won't be a solution. You can just check it out. Okay, so the superposition principle is not true for non-homogeneous linear ODE, and for non-linear ODE it will anyway not be true. Okay, so for non-linear ODE case also, here are some examples here. You can just check out whether x square and there y and 1 are there. Solutions are given to you. You can check out whether their scalar products or their scalar for example, their multiple scalar products, the scalar multiples. For example, you can check whether 2x square is a solution. You can check whether 3x square is a solution, or x square plus 1 is a solution. You can check it out. Okay, so you can see that they are not solutions. So this is not true even for non-homogeneous equations. Okay, so this superposition principle only holds for linear homogeneous differential equation. Okay, so that's it there. And moving forward, one more thing I have to tell you is that a general solution. So we have to remember thing. The general solution is a solution which contains arbitrary constants. A general solution is a solution which contains, just try to understand this, this is not the exact definition, but for your information I am telling you, a general solution is a solution which contains arbitrary constants. Okay, for example, in the earlier example I told you y dash is equal to y. Okay, you saw that y is equal to e raised to x plus c is a solution. Okay, so this is a general solution because it contains arbitrary solution. Okay, when I give values to this arbitrary constants, we will be getting particular solution. So I hope it is clear what do you mean by general solution. Okay, so general solution is a solution which contain arbitrary constants, and when you give values to this arbitrary constant, you will be getting a particular solution. Okay, so in as a rule, so these are basically a theory, so it is not required, but still I am telling you a first order equation, a first order linear equation, linear differential equation which contain one arbitrary constant. Okay, so, and similarly second order would contain two arbitrary constants. Okay, so idea is the first order differential equation will contain, the general solution of first order differential equation will contain one arbitrary constant, and the second order differential equation will contain, the general solution of that would contain two arbitrary constants, and nth order would contain n arbitrary constants. Only if there are two arbitrary constants we can call it a general solution. This is just for information I'm telling you. Okay, so moving forward. Okay, this usually the solution of a linear second order differential will be of the form y is equal to some c1 y1 plus c2 y2. Okay, we'll devise methods to find solutions of these forms, but try to understand now that the solutions will be of the form c1 y1 plus c2 y2, where c1 and c2 are constants and y1 and y2 are solutions called, these y1 are some, y2 are solutions. We are basically we'll call it as linearly independent solutions. I'll explain this term when we come to that section later. Okay, so I'll tell you what do you mean by linearly independent functions. So I'll explain it when we'll come to that section. So before that, try to understand that the general form of solution of a a second order linear differential equation is of the form C1 by yn plus C2 by 2. Okay, so this is general form of equation, and we'll later on explain why is it so. And they are these solutions y1 and y2 are called actually the fundamental set or basis of that solution. Okay, why is it called basis or fundamental set? Because all other solutions could be derived using these, could be obtained using just these two solutions. For example, in a real problem, we saw that sin x and cos x were solutions of y double dash plus y is equal to 0. Okay, so using this sin x and cos x, you could generate many solutions. For example, I could generate sin x plus cos x, or I could generate 2 sin x minus. So using this sin x and cos x, we could create many solutions, etc. Okay, so actually that we'll study later on that the only solutions of this differential equations are of this type only. For example, it will be of the form some c1 into sin x plus c2 into cos x. So all the solutions would be of this form only. Okay, so that is why the sin x and cos x are called the basis or basic or fundamental set of the solutions. Okay, so we'll study more about this concepts later. So try to now understand that the solution of a linear differential equation will have the general form of c1 y1 plus c2 y2. So this is the general solution of a second order linear homogeneous differential equation. Okay, this is general form. Okay, now I'll tell you methods to find the general solution. Okay, so it will be given a second order linear differential equation, you will be asked to find a solution. Okay, so its solution is of this form. We will be specifically solving second order linear homogeneous differential equations with constant coefficients. Okay, so you know that second order linear differential equation is of the form y of x plus y double dash plus p of x into y dash plus q of x into y is equal to 0. Okay, so in particular, we will be solving those equations of the form in which this p of x and q of x are constants. For example, it will be like y double dash plus maybe 2 into y dash plus y is equal to 0. So basically, we will be solving those linear homogeneous differential equations in which this p of x and q of x are constants. So we will be solving second order linear homogeneous differential equations with constant coefficients. Okay, so let us see how to do that. Okay. Now you will be asked, you will be given a linear differential equation, and you will be asked to find a solution to that. Okay, so let us try to understand how to find the solution. Okay, it's very simple, very easy thing. So suppose you are being given a linear differential equation of the form. Suppose it is like this: y double dash plus 5y dash plus 4y is equal to 0. Okay, so you are being asked to find the general solution of this equation. You know that the general solution to this equation is of the form y is equal to c1 y1 plus c2 y2. Okay, so I am going to explain the working procedure to you. So when you are being given an equation like this, the first step is you have to write the characteristic equation to the solution. There is an associated equation to this this differential equation. It is called the characteristic equation. Okay, so for first step is you will be writing the characteristic equation to this differential equation. So what do we mean by characteristic equation? It's very simple. You will replace the derivatives by the term lambda. Okay, so if there are second order derivatives, you will use lambda square. If there is first order only, you will use only lambda. If there is third order, I'll use lambda cube. Okay, so we'll just replace the derivatives using the term lambda. Okay, so this equation will be simply lambda square plus 5 lambda plus 4. Okay, there is no derivative, so I'll just write it 4. So for y, I'll replace it by 1. For y dash, I'll replace it by lambda. For y double dash, I'll replace it by lambda square. For higher order also the same concept will go. For y double dash, triple dash, I'll replace it by lambda cube. So I hope it is clear how to write characteristic equation. So we'll do it once again. So for example, your equation is y double dash plus 2y dash plus y is equal to 0. So how will you write the characteristic equation? It is simply lambda square plus 2 lambda plus 1. Okay, this is clear. Okay, similarly, suppose I am writing it as y double dash plus y dash plus 1. Okay, so how will you write the characteristic equation? Simply lambda square plus lambda plus 1. Okay, so this is how you write the characteristic equation. So first step is write down the characteristic equation. The second step is solve it. So you are getting a quadratic equation now. You find the value of lambda. So solve it. So second step is solve it. Okay, so when you solve equation, you can either use your calculator, scientific calculator, you will get the roots, or you can use the formula lambda is equal to minus b plus or minus root of b square minus 4ac by 2a, or you can factorize it. There are many ways to find the solutions. So please use any of these methods. You can either use your scientific calculator, you can find solutions. The method could be found in any YouTube videos, how to find the solution of a quadratic equation using scientific calculator. Because you can use scientific calculator, Okay, or you can use this formula, the quadratic formula, which is minus b plus or minus root of b square minus 4ac by 2a. Okay, or you can factorize also. So if you look at the solution of this water solution, you can see that the solutions are lambda is equal to minus 4 minus 1, right? Because I can factorize it as lambda plus 4 into lambda plus 1. So this is a solution. Lambda is equal to 4 minus 4 minus 1. Okay, so you have many cases can come. Okay, sometimes you will be getting real and distinct roots. So in this case you are getting real and distinct. Both the roots are real numbers, and they are distinct also. Okay, so you know that the solution of quadratic equation depends upon a term called discriminant. Okay, so if the discriminant is greater than 0, you will be getting real and distinct roots. And you have also studied if discriminant is equal to 0, you will be getting real and equal roots. Okay, and similarly if discriminant is less than 0, you will be getting complex roots. Okay, and also you may have studied that the complex roots always occur in conjugate pairs. All these things you have studied in your lower classes. Okay, so I'm not going to that, but these are right. So you will have three cases. You will have real and distinct roots. You may have equal roots. You may have complex roots. So all these cases will be covered here. Okay, so suppose you first of you have homogeneous differential equation. First you write the characteristic equation, you solve it. So once you get the solution, the general solution will be of the form, simply it is simply y is equal to some c1 into e raised to lambda x plus c2 into e raised to minus x. So this is the solution. Okay, so that is if your solutions are lambda 1 comma lambda 2, your general solution of the form y is equal to c1 into e raised to lambda 1 x plus c2 into e raised to lambda 2x. So that is the result. So you don't have to study derivation, you just need to know this formula. It's very simple thing. Okay, now can you tell me what will be the general solution? Like if the roots are 1 comma 3, what will be the general solution? It will be simply y is equal to c1 e raised to x plus c2 e raised to 3x. Very simple thing. You can write in any order, no issue. You can write in any order. Okay, so I hope it is clear. Okay, in some other cases your lambda and lambda 1 and lambda 2 will be equal. So this is a general solution because it was a second order equation, so it had actually two constants also. That's why it's a general solution. Okay, suppose when you solve, you will be getting the roots as same. Suppose your roots are actually 2 comma 2. Okay, for example, in our second example as we took here, this was the equation because what are the roots here? When you solve it, you can say this is actually lambda plus 1 the whole square. So the roots are lambda is equal to minus 1 comma minus 1. Okay, so in that case your solution would be y is equal to c1 e raised to minus x plus so if I write c2 e raised to minus x also, because both are same, what will happen? This is same as equivalent to simply some big constant e raised to minus x, right? So this will not be a general solution because why? This actually contains only one arbitrary constant, because both these terms are actually same. So in effect you will have only one arbitrary constant. So if you write it of the form c1 e raised to lambda 1x plus c2 e raised to lambda 2x, what happens is that they will get combined into one constant because this lambda 1 and lambda 2 are same. So they should not combine together. So you can think of it like that. So to avoid them to combine, so to avoid them from combining, what I will do is that I will keep a factor of x here also. Okay, that is if your roots are simply lambda comma lambda, your general solution will be of the form y is equal to c1 e raised to lambda x plus c2 x e raised to lambda x. Okay, so this x is basically introduced to prevent it from combining. So think it like, so that's not the actual idea, but think it like this, so it will be easier for you to remember. Okay, so when I teach you higher order equations, so suppose your roots are for example 2 comma 2. So how will you write the solution? The solution will be simply y is equal to c1 e raised to 2x plus c2 x e raised to 2x. Okay, it's very simple thing. So later on I will teach you higher order equations. There in that case there can be 2 can occur maybe 2-3 times. How will you write in that case? In that case it will be simply, I am just mentioning it for your information, it will be simply y is equal to c1 e raised to 2x plus c2 x e raised to 2x plus again that should not combine, so you will again reply c3 x square e raised to 2x. So you will put x as many times they are repeated. So if it repeats one time, I will just put x. If it remains repeating 2 times, I will put as x square, etc. So this is the general solution in that case. We will come to that later. Okay. So I hope these two cases are clear now. So one case is the roots are real and distinct. Suppose your roots are lambda 1 comma lambda 2. Then your general solution is y is equal to c1 e raised to lambda 1x plus c2 e raised to lambda 2x. Okay. Suppose you are getting your roots as real and equal. Okay, so in that case both your roots are lambda. So in that case your general solution is y is equal to c1 e raised to lambda x plus c2 e raised to lambda x. Okay, and one more case is left, that is actually complex roots. Okay, and you always know that complex roots occur in conjugate pairs. Okay, that means if 1 plus I is a solution, 1 minus I also will be a solution. So that is the, so always complex conjugates, complex numbers occurs in conjugate pairs. Okay, so in that case what you will do is that it's a very simple thing. So the general solution will be of the form y is equal to e raised to ax into cos bx. Okay, 1 second. This will be of the form e raised to x into cos bx plus sin bx. You might think it's very simple, very difficult. It's a very simple thing, because if you remember the earlier thing, these are actually two different roots, right? So when I write the solution, I'll write this as y is equal to some c1 e raised to 1 plus I into x, okay, plus c2 e raised to 1 plus I into x. Okay, so 1 plus I into x. Okay, 1 second. c2 e raised to 1 minus I into x. Okay, so this is just for information I'm telling you. It's not required for you, but still for understanding I'm telling you. So I can write this as actually c1, okay, e raised to, okay, before that I'll use the notation of a and b so that you will understand better. Okay, I'll just use this notation. Suppose your roots are a plus bi. Okay, so suppose it is c1 e raised to a plus bi into x plus a2 e raised to a plus bi into x. Sorry, a minus. Okay, so both roots are there, a plus bi, a minus bi. So it is a minus bi into x. Okay, so I can write this as, again I can simplify this as c1 e raised to ax, right? Okay, into, okay, this actually c1 is there, some c1 is there, c2 is there. Okay, c1 e raised to ax into e raised to bxi, right? Okay, plus c2 e raised to x, then e raised to minus bxi. Okay, so I can take this e raised to ax outside, right? Okay, and we also know that e raised to I theta, we studied in lower classes, it's equal to cos theta plus I sin theta. When you study complex numbers, you may have studied this relation called De Moivre's formula. Okay, so that's the thing here. E raised to I. So base, what is e raised to I bx then? E raised to I bx is nothing but cos bx plus I sin bx. Okay, similarly, what is e raised to minus I bx? E raised to minus I bx would be cos minus bx, okay, plus I sin minus bx. So you know that cos minus theta is cos theta, so it is simply cos bx minus I sin bx. So when you add these things, what will you get here? You will be getting this as c1 into cos bx plus I sin bx, okay, plus c2 into e cos bx minus I sin bx. Okay, so when you combine it, you will get this as e raised to ax into some constant. Some I can write maybe some k1 into cos bx plus some constant into sin bx. So that is how that general form came. Okay, so this actually coming from the first one itself. Okay, so if you have the roots as, so I'm generally writing, suppose your roots are of the form a plus or minus bi, that means the roots are complex. Your solution will be simply y is equal to e raised to ax into some c1 into cos bx. So c1 is basically a constant, c1 into cos bx plus c2 into sin bx. Okay, so I hope it is clear. For example, if your roots are 4 plus or minus I, how will you write the solution? It will be simply be e raised to 4x into c1 into cos x plus c2 into sin x. Okay, if it is 2 plus or minus 3i, how will you write? It is simply e raised to 2x into c1 into cos 3x plus c2 into sin 3x. So I hope it is clear the case of complex roots also. Okay, so now we have discussed the solution formula of so only these three cases will be there, so we can find the solution of any homogeneous linear differential equation. We will come to that now. Okay, so I hope all these are clear to you now, and sometimes they can also give some extra conditions to determine the constants of c1 and c2. So they will tell you that maybe y of 0 is equal to 1, or they will give some other condition also. So then in that cases, those conditions are actually given to you to find the value of the c1 and c2. Okay, so you can do that. We'll do that problem that now. So before that, let us try to solve this problem. Y double dash plus y dash plus 1 is equal to 0. So what are the roots here? So it is minus b minus 1 plus or minus root of b square 1 minus 4ac. Okay, 4ac is actually 1 minus 4 by 2. So it is minus 1 plus or minus root 3I by 2. Okay, so now can you write the solution here? Solution is basically y is equal to e raised to minus x, okay, into c1 into cos root 3 by 2x plus c2 into sin root 3 by 2x. Okay, so I hope it is clear. Just write the roots and then substitute there. So this is how you will solve the homogeneous linear differential equation, and that's the end of your first section. Okay, so we'll see some more problems here and then we'll wind up. Okay, so I have summarized all these methods here. Okay, just go through that, try to understand. Okay, so just go through this method. So very simple thing, just first step is you have to try the characteristic equation. I hope it is clear how to try the characteristic equation. You substitute y as 1, you substitute y dash as lambda, y double dash as lambda square, etc, etc. So since it's second order, we will only have up to lambda square. Later on we will study higher order. In that case we will have y double dash will be there, y triple dash will be there, y raised to 4 will be there. So that in that case we will have lambda cube, lambda 4, etc. Okay, and then you find the roots. You can find the roots either using your calculator, or you can use quadratic formula, or you can use factorization method. Anyway, we will find the roots, and there will be three cases. There will be their roots will be real or distinct, or it can be equal, or it can be complex. And when it's complex, you know that they are in conjugate pairs. Okay, so all these three things can happen there. Okay, so look at that. And moving forward, some examples are given to you here. Let us look at some examples here. Okay, so you have an initial value problem here. So I have given the examples of all these three cases. So suppose you have an equation like this, y double dash plus y dash minus 2y is equal to 0. So first I will write the characteristic equation. How will you write it? It is simply lambda square plus lambda minus 2 is equal to 0. Okay, so we have written the characteristic equation, and now this information is given to you. Y of 0 is equal to 4, y dash of 0 is equal to minus 5 is basically given you to find the solution, the value of the constants, etc. That will be doing in the last phase. Okay, so these information is basically given to find the value of C1 and C2. Okay, so that we will do once we find the general solution. Okay, so now we have this equation. Okay, then you now try to find the roots of that. You can use quadratic formula, or you can use calculator, whatever it may be. You will find the roots as actually 1 and minus 2. So here the roots are actually 1 and minus 2. So what will be the solution now? The solution will be y is equal to c1 into e raised to x plus c2 into e raised to minus 2x. Okay, so this is the solution now. Okay, I hope it is clear. Okay, now we will use this information. It is given to you that y at 0 is equal to 4. So you have to put x value 0. The value of y would be 4. So what will you get? You will get as 4 is equal to c1 into e raised to 0, which is 1, e raised to 0, plus c2 into e raised to minus 0, minus 0. So it will again be 0. So it is actually, you will get this as one equation would be c1 plus c2 is equal to 4. Okay, okay, and it is again given to you that y dash of 0 is equal to minus 5. So what will you do? You have y. First you find y dash. Okay, first you find y dash. So what is y dash? Okay, one more thing, y dash of 0 does not mean taking y of 0 and then taking derivative. Okay, in that case we will always get the value of 0 only. Okay, why? Y of 0 is basically a constant, so don't take derivative of y of 0 because it's a constant only, you will always get 0. So y dash of 0 means you take y, then you take its derivative, take the function y and find its derivative and then substitute the value of 0. Don't confuse it. Okay, so first you find y dash of y dash. Now what is y dash? Y dash is actually again c1 e raised to x plus c2 e raised to minus 2x into minus 2. Okay, now y dash of 0 would be again c1 plus c2 into minus 2, or you will get as c1 minus 2c2, and what's the value of that? It's going to be minus 5. So the value of c1 plus c2 was 4. You can solve these two equations and find the value of c1 and c2. Please try it out, and the value of c1 and c2 is simply 4 and minus 5. So the value of c1 and c2, try to find the value of c1 and c2. Okay, so what will be the value of c1 and c2? So if you just subtract it, you will get this as minus 3 c2 is equal to minus 9, or c2 is equal to 3. So and similarly c1 is equal to 1. Okay, so the general solution, so the particular solution here in this case would be simply y is equal to e raised to x plus value of c2 is 3, so it is 3 e raised to minus 2x. 3 e raised to minus 2x. Okay, so very simple thing. Okay, so moving on, here is an example of an initial value problem in which there are equal roots are here. You can see this equation. First step, write down the characteristic equation. It is lambda square plus lambda plus 0.25 y. Okay, you can use scientific calculator. Use that to find the formula. You can use the formula. Using scientific calculator, you can find the roots there. Here the roots are actually minus 0.5 minus 0.5. It is the double root. You can use your scientific calculator there. Or if you consider this as simply lambda square plus lambda plus 1 by 4 is equal to 0, then also you can find the solution as lambda is equal to 1 by 2. Okay, from there you will get, so you can use the calculator to find the roots. Okay, so lambda is equal to minus 1 by 2. Okay, so since the roots are just the same, you will have the solution as y is equal to c1 e raised to minus 0.5x plus c2 x e raised to minus 0.5x. So this is solution, and they have also given some two information to find the value of c1 and c2. Please do that. Put the value of x as 0, put the value of x as 0 here, then you find y dash, put the value of x as 0, you will get two equations in C1 and C2, solve it and you will get the answer. Okay, please try it yourself. The solution is C1 is 3 and C2 is minus 2. The solution will be, when you substitute it, you will get as 3 minus 2x into e raised to minus 0.5x. So please do it yourself. Okay, and moving on, the last case, which is complex roots, the same idea will be there. You will have an equation, write down the characteristic equation, solve it, and you will get the roots. Here the roots are minus 2 plus or minus 3i, minus point plus or minus 3i. You can find it using a scientific calculator. Okay, or by using the formula minus b plus or minus root of b square minus 4ac by 2a. I am not going to do this because it's basically a rote computation only. There is nothing new is there. Only computation is required. Just substitute the value and then read out the values only. So you can find the solution by yourself. Okay, so you find the solution there. Okay, so once you find the solution, you can write the general form here. Okay, and then you can use this values to find the value of a and b. So I or b or c1 and c2. Okay, so when y of 0 is equal to 0, what will you get? You will get the value as y is equal to a. Okay, y is equal to a, because this will be 1, this will be 0, so the value of a is actually 0. Okay, so your solution is simply e raised to minus 0.2x into b sine 3x. Now you use this formula. For that you again take y dash. So y dash, when you take, you will get as, you will get a product rule there, so you will be getting this quantity. Again you apply x is equal to 0, then you will be getting this solution. Okay, so that also we can do. So please do it by yourself. And here are some other examples also. I have also included some exercise problems here. Okay, so try to go through these problems and try to do it by yourself. It's a very simple thing. So you can find general solution here. You can find initial value problems here. Okay, so I am giving you another problem also here. So if you look at these set of problems, these are also actually very simple. Okay, you need to actually construct a differential equation from its solution. Okay, so if you look at this problem here, I need to construct a differential equation here. Okay, so already they have given the solution as e raised to 2.6x and minus 0.4436. So you can see that lambda is equal to 2.6 and lambda is equal to minus 4.3 are the solutions of that characteristic equation. Okay, so what will be actually your characteristic equation? So you know that if alpha and beta are solutions, then x minus alpha into x minus beta will be the actual equation. Okay, so your the roots of the characteristic equations are 2.6 and minus 4.3 here. So what is your actual characteristic equation? It is basically lambda minus 2.6 into lambda plus 4.3 is equal to 0. Multiply it, you will get it as some lambda square plus some constant into lambda plus some constant. From that you can see that differential equation was y square plus this constant into y dash plus some y is equal to 0. Okay, so please try to understand that problems also. So this is also very easy. So you can, I hope you can do these problems also here. Okay, so in this case you can see that the roots are actually minus root 5 only, so it's a double root there. That also you can easily find it out. Okay, and here you can know that this is actually the complex root, so we are getting cos 2 pi x and sin 2 pi x. In that case, that means the root was plus or minus 2 pi I, because there is no factor of e raised to x, so the roots are actually plus or minus 2 pi I in this case. Okay, so please go through that problem and try to do that also. Okay, I'll give you some homeworks also, and also in the contact class, live class, we will be discussing some of these problems also. Okay, so that's it. So we'll stop here.